Problem 17. We want to get 17 is the odd number out here. We want to get it over to the other side. We subtract 17 from both sides. We are left with negative 3x on the left-hand side. And 8 minus 17, we know is going to be a negative number because this is the bigger of the magnitudes, is the negative number. 17 minus 8 is 9. Therefore, 8 minus 17 must be a negative number, and size must be negative 9. We divide both sides by negative 3. We divide this side to get x all by itself, but we have to divide this side too in order to get balance. Left here with negative 9 divided by negative 3 is a positive number, and it's positive 3. Let's check and see if it works out. Negative 3 times 3 is 9. 17 minus 9 is 8. It does work out. Problem 8. 8 is the number that's all by itself on the wrong side. We want to get rid of that. We correct that by adding 8. But if we add 8 to the left-hand side of the equal sign, we must add 8 to the right-hand side of the equal sign as well. Result is we have 3x on the left-hand side and 10 on the right-hand side. These ones where it doesn't divide evenly are the ones where people are most likely to kind of mess up. So again, focus is on what you're trying to do next. So we're just focusing. We got this 3x. We ultimately just want it to be x. How do we make that happen? We make that happen by dividing it by 3. But if we divide the 3x by 3, we must divide 10 by 3 as well. And so we're left with x equals 10/3. There are no factors of 3 up in 10, so that's about as simple as far reduced terms as it goes. Well, let's check and see if it's right. 3 times 10/3 is going to be 10. 10 minus 8 is going to be 2. It checks. Number 9 is where things start finally getting a bit more complicated because we've got both numbers on both sides and letters on both sides. Arbitrarily, I'm going to choose that this side is where I'm going to want the letters to live, and this side is where I'm going to want the numbers to live. So if I want all the letters over here on this left-hand side, this 3x has got to go somehow. And we get rid of it by multiplying by, or adding, 3x. A lot of people want to multiply or divide here. The problem is it's not just the 3 that has to go, it's the 3x has to go. So we add 3x, but if we do that to this side, we have to do it to this side too. This side we're left with just 15 on the right-hand side. On the left-hand side we're left with 18x minus 3. Now we're back to, we've changed it into one of the previous 7 or previous 8 problems. And it's got this 3 that's out of place, so we add 3 to both sides. And that leaves me with 18x equals 18. Now we want to get x all by itself. We divide by 18, but if we do that on the left, we have to do that on the right too. And so we're left with x equals 1. Checked it in the original. 15 times 1 is 15, minus 3 is 12. So there's 12 on this side. 3 times 1 is 3. 15 minus 3 is 12. There's 12 on both sides. The equation checks. Yeah.
Could you, I thought that might be one of those you call the any number.
Pardon me?
You remember you did the jump over, you can put any number in.
Oh, I think he's talking about identity and...
Yeah, identity. Yeah, this isn't one of those. If you tried 2 in here, 15 times 2 is 30, minus 3 is 27.
Yeah.
15 minus 3 times 3 is 15 minus 9 or 6. Only 1 works in this one. We have some identities and contradictions coming up. But this isn't one of them. Problem number 10. Again, let's put the letters over here on the left-hand side, the numbers over here on the right-hand side. So if we want no letters over on this side, we have to add 3x. Now I've got 5x plus 4 equals 6. All the numbers over here I have to subtract 4, but if I do it on the left, I have to do it on the right. I've got 5x equals 10, 5x, then only equal to, it looks like, 2. Divide both sides. I'm going to rewrite this. Divide both sides by 5, and I've got x equals 2/5. That's going to be harder to check, but let's do it. 2 times 2/5 is 4/5. 4/5 plus 4 is 4 and 4/5. 2/5 times 3 is 6/5. 6 is 30/5. 30/5 minus 6/5 is 24/5. And 24/5 is 4 and 4/5. So both sides do end up checking. Problem number 11. Again, let's get the letters over on the left, the numbers on the right. To get the letters all on the left, I have to subtract 7x. Now, some people's preference here is to avoid negatives in front of the x. That's fine. You can do that by subtracting 2x and going with letters on this side, numbers on this side. I'm just sticking consistently to my pattern, though. So that ends up with negative 5x minus 5 equals 10. Now I need to get all the numbers over here. I have to get rid of this 5. But if I get rid of this 5 by adding 5, I have to add 5 on the other side. I've got negative 5x equals 5. Let me rewrite this over here so we can divide both sides by negative 5. 5 divided by negative 5 is negative 1, not 1.
Isn't it 15 though?
Is it 15?
It is.
Let's check
10
it.
plus
It
5
is.
is 15.
Gosh, life is hard.
It is.
Okay, so 15 divided by 5 is what?
Negative 3.
Negative 3. We could have gone away with showing an answer that doesn't check. It caught me on time.
Sorry.
So now we check. That's okay. We got to check negative 3 in here. 2 times negative 3 is negative 6. Negative 6 minus another 5 is negative 11. 7 times negative 3 is negative 21. Negative 21 plus 10 is negative 11. Both sides are equal. It checks. Last one here requires a little bit of work before we go to subtracting things because we got like terms to gather. So we got this 2x and this x on the same side of the equation. Let's get them together first. It keeps the confusion down to have all the like terms gathered. So 3x minus 5 is how the left-hand side stays, but now this becomes 3x minus 5. Oopsie! Is that ever false? Is 3x minus 5 ever not equal to 3x minus 5? No. So you've got a statement that is always true. And statements that are always true have all real numbers as their solution. That is what the textbook referred to as an identity.